homework assignment first, and then we'll talk about the new one. Okay, so that's going. All right, so this is the homework assignment that was due about 2 minutes ago. And I'm just going to give you the solution to this, or a solution. Okay, when it comes to the implementation of something, there are enough alternatives to do it that only no two people in the class should do it exactly the same way. Okay, there may be some similarities, okay, that is given, but exactly the same is highly unlikely. So in this game, we have 5. We need to catch the ball 5 times. And each time the ball will only stay in place for 2 seconds, and you have to move a sprite to catch the ball. And 5 times later, you finish the game, and that's it. And it keeps track of the time too. So we'll go ahead and read this sequentially. Drag an item to collide with the ball, and this item is going to be a sprite to collide with the ball. Do this 5 times and the game concludes. The ball only stays in place for 2 seconds at a time, and then it will change its location randomly. And may I also say it's going to do so in a quantum way. So it's not going to move continuously from one spot to another spot. It will just disappear from one spot and then reappear at another spot. Yeah. The screen design is easy. You just have a canvas where the user would do the interaction, and then a label to display how many more collisions before the game is going to conclude. Yep.
I have a question. Is it possible to put the label on top of the canvas? Because it seems...
Yeah, it is possible.
App Inventor was forcing me to kind of put them in 2 different categories, and I'm like, I want to put this label Z-axis above the canvas.
Well, we can give it a try. The behavior of the app is the game will start as soon as the app starts. The canvas will have 2 sprites. The first sprite is a ball, and the position is controlled by the blocks. So this is the part where your program controls. The second sprite is an image, and the position is controlled by the end user dragging the sprite. And some of you, made it fancy so that it would actually reflect the direction of the drag. Okay, so that's kind of cool. Once a ball is hit by the second sprite, decrement the remaining number of collisions and immediately move the ball to a different position. If a ball is not hit in 2 seconds, move the ball to a different position. The game concludes after 5 collisions, 5 hits. When the game concludes, use a notifier dialog box to inform the user the game has concluded. So you don't even have to time anything, okay? Except for the 2 seconds before the ball goes to another location. All right. So what I'll do is I'm going to give you my solution, unless you guys say that you all have a solution to this problem and you don't need to look at my solution. Okay, how is this going to be? I mean, do you guys all have turned in a solution, or okay? All right. So if in that case, I'm not going to give you the solution. Yep.
I have a question. Suppose I accidentally didn't make the target a ball.
You make it just a general sprite?
Yeah.
I'm not going to take too many points out. Yeah. Or any.
I didn't read that app part.
Okay.
So I just put a little Cory on it there and made this dragging thing.
It's not going to be a big deal because the real essence of this homework assignment is to make sure that you guys know how to make use of the canvas and how to make use of the sprites for this purpose. So the next homework assignment is get them all, which I'm pretty sure is not a slogan mark by Pokemon, of course. Okay, so this one is very similar, well, in a way similar to the other one. Okay, so I'm just going to go through the design. The app only has 1 screen, or screen 1. The component of screen 1 should include the following: a canvas area where the user would do the interaction, a multi-purpose button. Okay, so I'm trying to minimize the number of buttons, so it's context sensitive. What the button is going to do is context sensitive, and it will be described later on. What context, in what context, what is it going to do? And also a label for status score purposes, and we'll call it just the label. So we have the canvas, basically the button, and also the label. 3 components in this case. Okay, the behavior of this particular program that you're going to write is when you start the application during initialization, do not start the game automatically. The text of the multi-purpose button should just say start. So when people click on the button, it will start the game. And the label is just saying, okay, let's start the game. Is that okay? So that's the initial state of the app itself. Upon clicking the MP or the multi-purpose button, if no game is currently in progress, in other words, this is the first time we got here, or a game has already concluded, well, actually, I take that back. If there's no game in progress, in other words, this is the first time we got into the app, then what you want to do is to start a new game. I'll describe the game itself in a later section, and also update the text of the multi-purpose button. So instead of saying start, it should now say pause, so that when the end user clicks the button, it will just pause the game. Is that part okay? All right. On the other hand, if a game is already in progress, in other words, the game has already been started, then you want to check whether it is currently paused or not. If it is currently paused, then you want to resume the game and also change the text of the multi-purpose button back to pause. On the other game, if the game is not paused, okay, it is going and it is not paused, then you would pause the game, which is basically just stopping a timer, and update the text of the multi-purpose button to resume. So you will allow the end user to pause the game and then resume the game by clicking that button. It becomes a toggle during the play of the game. If a game has already been concluded, okay, if somebody actually finished a game, then clicking this button is going to reinitialize and start a new game.
And it should say, when game concluded, it should say start again on the button on the label, right?
That is described later on in another chunk. Yep. So upon long clicking the multi-purpose button, okay, it only is meaningful. This particular event of long clicking or long pressing is only meaningful when a game has already been concluded. So if a game is concluded, has not been restarted yet, and you do a long click, it will reuse the same 7 positions as the game that has been concluded, and you start the game but reuse the positions. So we'll to know what 7 positions we're talking about, this is how the game is played. So for initialization, the first thing you want to do is to clear the background. Okay, make sure there's nothing on the background. You want to specify a particular background color. I do not limit you to use which color as a background. Try not to use really annoying, not just contrasty, but really annoying background colors as opposed to the foreground colors. Then what you want to do is to draw. Okay, remember, do not use ball sprites, but actually draw 7 circles that are filled at different positions of non-overlapping different coordinates of the screen. Okay, I do not specify the width or the size of each circle, so you can pick, you can make it randomized if you want to. Okay, but it has to be a color other than the background color itself. Okay, and these are drawn; they are not sprites. The filled circles must be of a color that is different from the background, but between the circles, they can be different colors. So you can make it a rainbow color, okay, if you want to. Okay, just choose all the different colors. At the center of the canvas, you want to place a small ball sprite. Okay, so you do have one sprite in this app, which is a small one, and you initialize that to be at the center of the canvas. Yep.
So the colors, the circles can be all the same color, or you want them all different colors?
They can all be the same. They can all be different. The only requirement is they have to be different from the background. Okay, because if they are in fact the same as the background, then you cannot see them. And because none of them is overlapping and you cannot see them, that means you just have one fewer ball to begin with. Now, if they do not overlap, if they do overlap, at least you can see the effect of one ball on another one, or one circle on the other one. But since they cannot overlap, so they all have to be different from the background. And then also, when you start the game, you want to start the timing mechanism. Okay, so when you click start the game, then you start the timing mechanism. The gameplay is like this. When the game is in progress and is not paused, the label should display the number of seconds from the start of the game, and it should be updated every second. Okay, so all you have to do is to say, okay, this, you can just use a number if you don't want to say this number of seconds has passed. Okay, so you can just display 1, 2, 3, 4. But when it pauses, then you have to stop updating the clock. Okay, so you have to stop counting when the game is paused. When it resumes, then you continue counting from where you left off. Okay, so don't worry about the fraction of a second, because when you click the pause button, okay, you can be kind of like halfway through a 1 second cycle. Don't worry about it. Okay, just not count that fraction of a second. Okay, even though we did talk about how to deal with that in the previous class, don't worry about that one. When the game is in progress and paused, the number of seconds since the start of the game should also pause. Okay, don't reset it to 0. Just stop counting. Use the drag event handler of the ball sprite so that the ball sprite follows the finger of the player. So the player would basically just drag that ball around. Yep.
Did you upload that code that you did that fixed the counting the incremental timing? That you're just
I may not have uploaded that. I can do that. Yep. When the center of the ball sprite is over a painted filled circle, remove only that circle from the canvas. Now this part is tricky because it involves two things that are kind of tricky. First of all, how do we know the center of the ball sprite is over a painted filled circle? That's an easy one because you can check the color of the background. Okay, so that one is not too bad. Not the background, but you can check what is behind the sprite. You can check with the color of a pixel. So that part is not too bad. The bad part is, how do you remove that circle? It's not a sprite. You cannot just say, hey, sprite, hide yourself, do not show yourself. So you need to somehow track the 7 balls in your program. And then you say, oh, okay, the ball sprite is now over a particular one, figure out which one. Once you figure out that one, then you will make it go away because you can just paint the same box. You can paint the same circle with the color of the background. That's how you remove a painted circle from the canvas. Is that okay? All right? Okay. And you just keep doing it like this. The game concludes when all the filled circles are removed. Okay, so I'm going to do a really old technology emulation using the whiteboard. Which I'm pretty sure many of you will appreciate because I cannot do this too fast now, can I? So this is let's say this is the canvas, okay? The placement of the button or the label is entirely up to you, okay? Just make sure it is visible and we can actually click it. So I'm going to put the label up here and put the button down here. So initially it will say let's start a game, and then the button will just have the text of start in the button. In other words, the button always just says what is its current function. Is that okay? So this is how, and then this one is just saying let's start a game. Here we go. So this is the initial state of the entire game, the entire app. Okay. When you click the button, okay, I'm going to use the second part of the board here. Okay, so this is also a good time to introduce the concept of what we call a state diagram, which is also a part of the UML. What is the UML? What was the last time that we did something about the UML? The use case diagram. Yeah, we only use a use case diagram in this class. Activity diagrams are actually useful too, okay, but this is a state diagram. So the state diagram is basically transitioning from one state to another state by an event, okay, but in this case the event is the start button is clicked. So I'm just going to say click of some button. The only button, by the way, okay? So this is an event that triggers the transition from the initialized state to a game playing state. So in the game playing state, okay, this button will say pause because that's the function of this button while the game is ongoing. Okay. And then these parts will basically display the number of seconds. So you say blah, 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 seconds. You don't even need to use seconds if you don't want to, but it will just display a number, which is the number of seconds since the start of the game. Is that okay? All right. So this will keep updating. Okay, I'm going to use this symbol to mean that it is updating. Okay, every second it will update itself. But the initialization of the game will also place basically 7 painted circles on the screen. So I will just go ahead and paint over here, 2, 3, 4, 5, 6, and 7. They cannot overlap, okay? So when you try to figure out, okay, where is a good location to put the next painted circle, you have to make sure, before you paint it, you have to make sure it doesn't overlap with something that is already painted. So that involves a little bit of math, right? Okay, if you guys want to know, we'll talk about the math a little bit later on. Okay, so you have basically this, and then in the center of the entire screen, you would have a ball sprite. Now, how big you want to make this ball sprite doesn't really matter. You'll pick something that's reasonable. Okay. So we still do okay so far with this diagram. So now we transition to the next one. Okay, so another transition here into the next one. And there are multiple transitions from here. So the first one is, what if the end user clicks the button? Okay, so we have another button click. Button dot click. Okay. So if the end user clicks the pause button, what do? Well, we pause the game. When you pause the game, you want to change the button to spell resume, so that people know, okay, what does this button mean when I click it? So if you click the button when it's paused, it will resume the game. And then you don't want to keep updating these numbers, so stop updating that number. Is that okay? And you can go back and forth between these two. So if a game is already paused and you click the button, it resumes, and then you can go back and forth between these two. Is that okay so far? So this is also known as a state diagram. What if someone is dragging this thing? Okay, so when someone is dragging this thing, you can drag it to a point where it is the center of the sprite is over a painted circle or not. Okay, so the other one is not really that interesting, so I'm not going to say what's going to happen. So I'm going to draw another transition over here. And in this case, I am going to use this to represent the event. Okay. So the event is, you have the sprite, the center of the sprite being over a painted circle. Is that okay? Yes? Okay. So, so what's going to happen here is you will make that circle disappear. So let's just say that we are talking about this circle over here. So the end screen that you end up with is going to have all of the other circles, and the ball sprite will still be over the one that has been quote-unquote deleted, but all the other sprites will still be here. I mean, the other circles, excuse me, all the other circles will still be here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So then I'm missing 1, 2, 3, 4, 5, 6, 7. Okay, that's correct. Okay, so you basically want to make this one disappear. So I'm going to use a dotted line here to indicate that we are making that one disappear. Is that okay? So it will basically go, and this can repeat to itself. Okay, in other words, if you move the point here to another point, then you will delete that one until there are no more circles left. When there are no more circles left, then the game quote-unquote concludes. So when the game concludes, the game concludes when all filled circles are removed. When that happens, you want to change the text of the button to new game, but in parentheses specify long press, we'll do a retry. So this is the other part that is going to be interesting, because in order to retry the same game, you will have to remember the locations of the 7 painted balls so they can reuse exactly the same thing the next time. Is that okay? Yep.
There's 2 states from this point. One where you start the game with the previous setting, and one where you randomly start with another.
Yes. So a regular click will start a new game with all different painted ball positions, and then a retry will use the same 7 balls or the same locations as the previous one. Exactly the same. Yep. So you're going to retry the previous game using the same 7 balls, the same positions of the 7 balls. So the idea is this is an optimization problem. Okay. So given the initial state of the game like this, then you will try to solve the problem, like try to get rid of all of these painted dots using a particular route. Okay, and you're getting timed. And then you say, okay, well I did it with this number of seconds this time. Maybe I can do better. So you want to do a retry and do it the same but slightly differently and see if you can improve your time. So that's the nature of this game, is an optimization problem. Now in this version of the game, we're only tracking time, not distance. Okay, because I don't want to throw in distance just yet. Time we can track easily because we have talked about the timer already. So you can kind of imagine that you can keep this. You can alter this game, make this game a little bit more interesting by tracking the distance. So it's not really just how fast you can swipe or how fast you can drag the ball. It is now, it's timing, it's actually measuring the distance. So whether you go here like this, or whether you go here like this, the actual distance can be different. And you try to minimize the distance. You can also see how this can be a social game, where a server can synchronize two devices to basically have exactly the same configuration, and we'll see who can use the least distance to get rid of all the balls. Is that okay? But in this homework assignment, it's a single player game, no networking capability, but we do have a retry, which is actually not going to be a very big thing because you have to track the positions of all the balls anyway, in order to get rid of the circles when you have your ball sprite on top of it. Okay, are there any questions about the gameplay itself? Okay, so if I want to draw this picture, okay, there's one more state up here, and this state is basically a final state with no painted balls anymore, okay? The number here is not going to update anymore because the game has concluded. And then the button here is going to say, oh, okay, new game. In parentheses, a long click will do a retry. And then that can bring you back to this state here, which is in game. But it doesn't get you back to the initial screen. So when you click this button, either way, either a long click or a regular click will get you back here. The only difference is, are we using the same 7 positions as before or new random positions? And to make this game a little bit easier, you don't have to take care of the very rare possibility that the new 7 random positions just so happen to be the same as the previous random 7 positions, because the chances is really low, and I don't want you to have to spend any time to deal with that. So you can basically just say that randomness is random enough that it's unlikely that you end up with exactly the 7 positions. Yep.
Why can't the colored balls be sprites?
Because I don't want you to use sprites. I want you to use the calculations to figure out whether you have a collision with a painted ball instead of a sprite. So it was intentional, it was definitely just intentional. But the other part has to do with, what if you want to make this game more dynamic? So you would increase the difficulty, you will start with 3. Okay, so you have a match with somebody else, right? Okay, so you have 3 balls, 4 games, or some number of games. If there's a draw, then you increase the number of balls, okay? You increase it to like 6. and then 10 and so on until there's a clear difference between two players. But when you change the number of painted circles, the ball sprite approach doesn't work anymore because you can only have a fixed and constant number of components, which is a limitation of App Inventor itself. Is that okay so far?
Wait, can you say that again?
What did I just?
Change the number
Use
of
ball sprites, you can't.
You cannot manufacture
There's
ball
no
sprites.
new for a ball sprite.
You cannot manufacture ball sprites. In other words, let's say if I want to make this game so that the number of painted circles is dynamic, okay, and we start with 2 and then we gradually increase the number. Then in the case of using ball sprites, then you have to ask what is the maximum number and then create that many components to begin with.
if you're using ball sprites instead of painted circles?
Correct.
Okay.
Yep. But if you use painted circles, then it has no linkage to components. You only have one single ball sprite, which is the one thing that you're dragging. So the other part has no actual component representation, but you do have to have some kind of internal representation to keep track of your circles. Is that okay? Yep, question?
The button has a long click event.
Yes, the button has a long click event. Let's see, we go to App Inventor. And I can't remember which account I used last time. I think it was some profs, if I remember correctly, because I want to upload the finished project from last time too. So let's see, go back to projects. Was it replay that I worked on last time? According to this, it's directional. No, that's really old. Was it replay? I think it was replay.
Or that's the right date. That's the right date.
That's the right date. Yeah. So I can certainly download the AIA file. Yeah. So we can do that. So click that. Export the AIA file and save it into downloads. Okay.
Well, I thought you worked on it some more in lab, so that time wouldn't be right. Oh, modified 11. Yeah.
That's right.
So this is in class, and then the other one is in lab, right?
Yeah.
So the one in lab is probably from another account because I kind of chose the other account. Let me see which other account I could be using. Sign out. Why did I get back here? It's the cookies.
Same thing.
It's the cookies. Let's try this one. Oops. Maybe that. Yep. Great. My phone number is now displayed. And everybody on YouTube now know my phone number. They all call me for some random reasons.
I think you're more likely they're gonna sign you up for telemarketing services.
Okay, so it's not that one. I think by accident I used this account. Okay, let's try that one. Okay, it's probably this one. No. Oh, where did I put it? Too many accounts.
You should write an app to track your.
The only one I haven't tried is maybe this one. Nope. Not this one either. Okay, I'll find it during the lab time. Okay. So the question was long click. Okay, so answer that question first. So when you drag a button as a component, you go to the blocks and see what you can do with the button. It has a click and a long click. So those two are considered different events.
Does that long click have a parameter, or is it a set amount of time?
It's a set amount of time. I cannot remember how long.
Okay.
But basically, it runs a timer that is not visible to you. So when you hold on to the button, past that time, then it will trigger this. Okay. Any other questions? Okay, so there are a few math problems that you have to solve with this one, right? Because you have to figure out, okay, is the center of the sprite actually on top of a painted circle? Okay, that's the first question. So let's go ahead and take a look at that one and see if we can solve that mathematical problem. And I'm trying to figure out what to do with that. Oh, what the heck? I'll throw
So
you
it
guys
has
a
to be
bone.
in the center?
Hmm?
It has to be in the center?
The center of the ball sprite. A ball sprite is easy to work with,
What I
easier.
mean- The ball sprite has to be in the center of the circle, the outer circumference will not suffice?
It has to be on the painted circle, anywhere.
Anywhere on the field, but center of the ball sprite.
Yes, you only consider the center of the ball sprite. So the ball sprite, has to be, the center of the ball sprite has to be on top of a pixel of the painted circle. Okay. All right. So let's take a look at a canvas and see what we can do with that particular problem. Okay. So we'll use a canvas. And for the purpose of this particular program, I can make the canvas pretty much as big as it needs to be. As big as it can be, I should say. There we go. And then we'll go ahead and start with our program. So the first thing I'm going to do is to draw a circle. Okay, so drawing a circle is pretty easy. Go to canvas and just use one of the events here. I'm going to use touchdown to draw a circle. So I'm going to use the XY to draw that particular circle. So to draw a circle, you go to canvas and then you say draw circle. And when you draw a circle, you specify the center and also the radius. So I would just use this X for where I touch down. Use the XY coordinate of where I touch down as the center of the circle. And I just use a constant number. Let's say 20 as the radius. Here we go. And here's 20. So now I need another mechanism to basically specify a point and say, okay, is that point in the circle or not? Because I need to make that determination. So we'll go ahead and just randomize this whole thing. I'm going to use a timer and just keep poking until it pokes the actual circle. Okay? All right. So let's go back to the designer. And this time let's go ahead and put a sprite here. Okay? So when you do specify a ball sprite, do you guys remember whether the XY specifies the upper left corner or the center? The upper left. Okay, so it's not the center that we are using when we look at the X and the Y. Okay, so you got to be careful with this one, because you can always make this like really big. Okay, and by changing this, okay, putting it all the way up here, you can see the X and the Y are already going negative instead of 0. So when I'm here, I'm just trying to make it 0, but my mouse is not exactly very sensitive. That's close to 0, but okay, there we go. Okay, I can make X1, okay, because you can see that there's a little, I'm not sure whether you guys can see or not, but there's a little gap between the left edge to the left edge of the circle. Okay, so we know the X and the Y of a sprite is not reflecting the center of the sprite, it's actually reflecting the upper left corner of the sprite. But since you also know the radius of a sprite, it's not difficult to find out where's the center of the sprite. Is that okay? All right. So I'll make this a lot smaller. Okay, so we'll go back to a tiny little thing, like 3 pixels. And I'm just going to use a timer to kind of keep poking around with this little sprite ball here until it's touching the painted circle. Is that okay? And then it will stop. Okay. So in order to do that, I'm going to use a timer. So we go to sensors, drag a clock into this whole thing. And in this case, I can just make it fire like 10 times a second. Okay. And here we have the blocks. We go to the clock, go to the timer event, And every single time we have a timer event, we just want to, first of all, generate a random number so that I can place the ball sprite somewhere on the screen. Yep.
Sorry, can you explain how setting the interval to 100 is making it fire 10 times a second?
Because 100 milliseconds is the time interval,
Okay.
which is the time between the timer events.
Okay.
So there are 10 100 milliseconds in 1 second, so that's why it's the same thing as 10 hertz in terms of frequency.
Okay. Setting it to 1,000 makes it go off once a second. Setting it to 1 makes it go off 1,000 times a second.
Yeah, correct.
Okay, thank you.
It's only approximate. Okay, it doesn't really guarantee the timing to the milliseconds, so it's only like more or less a suggestion. Okay. All right. So every single time the timer goes off, I'm going to do this. So this is definitely not your homework. So do not copy this code in your homework, or do not copy the entire thing. So I'm going to use a move to, okay, and then change, and then you specify the XY as random numbers. So go to math, and we'll just pick out some random numbers. Okay, there we go. And we'll pick up another random number. Oh, okay, let's fix this one first. Okay. So 1 is good. Okay, we want to change this one to 0. 2. Okay, technically it really should not be 0 because if I put the center of the well, this is the left edge, so that's fine. Okay, so it can be 0 to the width of the canvas minus the radius of the ball sprite. Okay, so technically that's the entire range. So we want to take out this 100 as a constant. Go to math, specify a subtraction. There we go. And we want to refer to the width of the canvas. So we go to the properties of the canvas, find out where's the width. There we go. Minus the radius of the ball sprite itself. So we go to the ball sprite, go to the radius property. Now since it's the radius, you have to multiply 2 before you do the subtraction. So we do that. This is the joy of
Multiply 2 because you want the diameter. Why?
you get the diameter.
This is the left side.
But that's how we want to, but that's the last spot we can specify the x coordinate. So I think that is correct. Yep.
Oh, sorry, never mind. I was going to ask something else. So
Ah.
that's fine.
Okay. That's all right.
I just misinterpreted something. So that's it.
Well, it's difficult to read because of the kind of, it's good and bad because it's easy to read in a way, but it's very tedious. Okay. So with this, I'm placing the dot all over the place, and I'm just going to test this program as it is, okay, just to see whether I can put that dots randomly around and draw the circle where I click. I'm not even detecting collision here. All right, so let's go ahead and start. Well, with this, I can just use the built-in emulator because I'm not using multiple screens. I'm not using anything that is sensitive, so that we have to run an emulator separately. So we just go Google commands AI starter. Okay, there we go. Now we can switch back here and connect to the emulator. It will just take a little bit of time. I wonder if there are stupid games like this in the app in the Play Store already.
Let's find out.
Probably.
Because these are really easy to write games, but they can be addictive. It's the easy ones that are addictive, like Tetris.
Flappy Bird.
Flapping Bird, oh yeah, that one.
Fruit Ninja.
Hmm?
Fruit Ninja. Fruit Ninja.
It took a lot
Where
of
they
work.
grow up the
Got it.
and you gotta
Work.
swipe them.
Oh.
You not seen Fruit Ninja?
No, no. Mm-mm.
Freaking amazing. Here we go now. Let's check. Go half, right. Guy who I was internet game called Crossy Road. And
So that's a great game to play on the Twilight.
I actually had never heard of it until I saw his GDC talk, and I was like, oh.
Okay.
Okay.
So the second thing I have to test is whether my click on the canvas will actually draw a circle, and it does. So I can keep drawing more and more circles. But it has no detection, right? So it's just plotting the dots and randomly. Okay. Are there any questions about the app at this point? Not quite finished yet. Okay, no questions? All right. All right, so now we want to change this app a little bit and say, okay, if the random location of the ball sprite hits one of the balls that I have painted, okay, then stop. Is that okay? So let's go ahead and see. Yep.
You should just change the color of it.
Change the color of.
Of where
The ball, yeah, make it a random color each time.
Well.
Because if it just stops, it's black. I don't know what dot it stopped on.
Oh, you mean black on black? Well, that's easy. You can change this color of the ball sprite itself to something else. So we'll change it to, let's see, magenta. Okay, that makes it pretty visible, right? Yeah. Well, since we're on this, might as well change the color of the background to be green.
Oh. I love how all the default choices for the app are the worst. They're all terrible.
Or we can make it different shades of green. We'll call it camel.
Does it even have a custom? Can you do a custom color?
Yeah, you can. You can do RGB. You can mix your own color, so you can actually make it a camouflage kind of thing. So the ball is kind of like a shade of brown, and then the background is kind of like a variation of that.
Make it random if you wanted to.
You can make it random, but random is not nearly as fun as camouflage. Yep. And you can make it digital camouflage too, because you can just kind of use a random mechanism to walk the pixel in a certain color, and then pick another place and just walk in a random color too. That would make a really kind of interesting app. Okay, so now it's visible, and now the question is, how do I make that determination whether it is landing on the spot or not? So I'm going to do this in a way to make your homework a little bit easier by turning it into a procedure. So you can actually use the backpack to move something from here into your project. So we'll go ahead and do a procedure that returns a result. Okay. So let's name the procedure accordingly. Okay. So it's basically is XY in circle. Okay. In a particular circle. It's actually pretty easy to do because we know the background color, don't we? Okay, so let's go ahead and see what we can do with this. We need something that's more like this. Do something and then give me the result. Okay, because we will need that. And I'm going to use some local variables too. So I'm going to use this block, put this inside here, so I can use the local variable as a part of the result. There we go. All right, so in order to make this easy to read, I'm just going to use a whole bunch of local variables just to spell out, the logic of this code. So I'm going to specify background color, okay? So I'm going to set the background color to the background color of the canvas itself. So I go to canvas, go to its properties, and look up background color. So now, this is a background color, which is a list of RGB. Okay, this is a list of 3 values. The first one is R, and then red, and then green, and then blue in terms of intensity. And then each value is going to go from 0 to 255. Is that okay? So background color is a list of 3 items, and each item is a number that is from 0 to 255. Let's go ahead and add some more variables here. Okay. Okay, so in order to make that determination, I also need to know where is the ball sprite. Okay, so I'm going to put X here and then put a Y here. Because instead of using the inline way to specify this makes it a lot more readable. So x is going to be the x coordinate of my ball sprite. So here's the ball sprite. If you want to parameterize this any further, hey, be my guest. But I'm not going to spend the time to do it because I just want to illustrate the logic and the calculations. So we pick up y, and put it here. Okay. So the size of the ball sprite is actually useful, is important, because at this point I'm only looking at the upper left corner of the ball sprite, not the center of the ball sprite. So you will have to do something to calculate the center, which will look kind of like the reverse of this here. Okay, so you have to use the radius to help you find where the center is. But you always know the radius of a ball sprite because it is a property of the ball sprite. So that should not be a hard thing. Okay, so now that we have all of this information, yeah, it's pretty easy. In fact, I can probably just provide the result right away. Yeah, we can actually. All right, so we'll toss this because I can use a conditional statement right away, or even just a logic expression to do it. Okay, so we have to compare several things, and they all have to be true at the same time. What negation or the disjunction? Because I want to find out whether the ball sprite is inside the circle or not, which is not the background color, so we'll use a disjunction or. Okay. And we'll need 2 of these because we got 3 things to compare in order to make that determination. Okay, so what are we going to do with this? Okay, maybe one more variable can be useful. Okay, I'll call this color under xy. In other words, given this x and given this y, right? What is the color under that particular pixel? Okay, maybe I should use color on this pixel. Do we have a way to find out? Well, it will be under canvas, right? So if you go to canvas and you browse through all the blocks, okay, we got clear, draw, get. Okay, so now we have 2 gets, right? One is get pixel color, the other one is get background pixel color. Which one should I use? Background, because if I use get pixel, no. we have to use get pixel color because the entire background is one single color. We got that one already in the first local variable. We want to know what is the actual color being displayed on that pixel, not what is behind it. So get pixel color is the one that we want.
So get background pixel color, how is that different than just getting the background color?
In this case, they are identical. But when you use a background image, then you can only see whether this pixel
Use a background color.
Right.
You're looking at the pixel.
Correct. Yep.
So this doesn't interact with the sprites that are on top of it?
No. It does not. It should not reflect the color of the sprite. We'll find out. I don't think the sprite reflects.
Then, you're just going to return the color of the ball every single
Correct.
time, which is not.
Yep.
That's because of the z value.
It's because
sprite
of
is
the.
sitting on top of the z value.
Right. Well, a sprite is always on top of a background. It's always on top of what you paint. So there's no way to specify the sprite to be behind it. That's a good question. I like that question.
Because it's an object.
Well,
It's part of the canvas.
it is part of the canvas, so that's a good question. Because when you save, you do save the sprite itself. The sprite itself is being saved when you save the image. So that's a good question, whether it will do this or not. Okay, so let's go to canvas. It probably doesn't say anything. That's one thing I have noticed about the App Inventor documentation is, well, sometimes it doesn't really quite tell you what exactly it is doing. Okay, so let's go ahead and pick out get. Okay, get the color of the specified point. So it might actually be.
Here we go. Get background pixel includes any drawn points, lines, or circles, but not sprites.
But
So we
not
need
sprites.
background.
But that's background.
Yeah, we need background.
Yeah. and we
Oh, it
drew
includes
on the back.
drawing points.
Yep.
Okay. Okay, so that's what we need. Okay, good. So So it is helpful to read documentation. So we go back to canvas and use background pixel color because it excludes sprites specifically. So we get X and then we get Y. It doesn't like it when it's a local variable. Fine. Now the best way is to parameterize X and Y as parameters to the subroutine, but I'm too lazy to do that. Alright, so now we have the background color of the canvas, which is how you which is a property. Let me highlight which one. This is a property of the canvas, regardless of what is currently on the canvas. This is a property that is saying, okay, when I clear the canvas, everything's going to be this color. This one is really what is currently on top of that pixel. So it would include the painted balls, but it will exclude the sprite itself. Okay?
What the other one use?
The other one?
Yeah, get background.
Yeah, the background color is what it would use to repaint the entire background when you clear.
Okay.
Which means, if you have drawn a lot of stuff on the canvas already, that you may not have a single pixel that actually has the quote-unquote background color as a property of the canvas.
Okay.
Because that really is just, when I restart, when I repaint the entire thing, what color is it gonna be? Okay. So we are looking at the difference between the colors. So the first thing, being lazy as I am, I want to see if there's a quick and easy way to compare colors. So we go to colors, and then we go like, okay, we have certain constants, great. We can make a color, which is a RGB using 255, 0 to 255. We can also split the color into RGB, but there's no easy way to compare two colors. Now, if you find comparing colors to be useful, whether they are equal or not, make a subroutine to do it, okay? Which is probably what I should do. I'm just going to demonstrate how to do it here. So I'm going to write a subroutine to compare two colors and report back whether they are the same or not. So now we have a new procedure, and we say different colors, and it has to compare two colors. Right? So we need two parameters, and let's call this color 1, and we'll call this color 2. There we go. So if I don't feel like using local variables, I can just use a bunch of ORs and a whole bunch of split to do it, which is going to be a little bit tedious, but it's doable. Or I can do it in the loop. Because there are 3 items to compare, we can do it in the loop as well. So let me see, what should I do? What should I do? Yep.
So color is a data type?
Is what?
Is it a data type or an object?
It is a data type.
Okay.
So you have to convert it into a list first, and then we can compare two colors. I'll just do it the long way. I'll do this the long way first, and then you guys can try to optimize it and use a loop or whatever. Okay, so we'll do it the long way. So doing it the long way means, if I know that this is a color, if color 1 is a color 2 is a color, then I first need to use a split color to make it into a list, right? So we split the first color, duplicate, split the second color. Oh, it doesn't let me do that. Yeah, because it's not in there. Fine. Okay. But this will give me a list of 3 items, and I don't have a compare for list either. So now we need to do a select. Okay. So we go to list, and then we say select. This is going to be very tedious. And then we say find the first color, which is red, and then we do the same thing over here. So we just
Why can't the better one do that, or will he just type in numbers?
it won't.
I don't want.
You have to be selecting the block first, though. Okay, and then we need to compare. So we are comparing this to this as one component of the OR. And once we have it here, we can change the color 1 back to color 2. All right, so let's take a look at this code and see what it's doing.
We're doing the loop. All we're doing is change that index.
Yes. Which is every time you use copy, paste, and modify, you have to ask yourself, is there a better way to do this? So we'll just go ahead. No, do not. There we go.
Yeah, I was wondering.
No, it's an or because we're looking for differences.
Oh, yeah.
So I have to change the difference, the nature of the comparison. So we're looking for the colors to be different.
Oh, okay.
Yep.
So I was wondering where you're going with or also.
No, because the subroutine is asking, do we have different colors, right? There we go.
Nope, change to 3.
Oh yeah, copy, paste, and modify. I hate that.
I think my least favorite thing about Epic is how long it gets.
Yes. Okay, so when this entire expression is returning a true, it means I have found at least one component, R, G, or B, being different between the two colors. The only time it's going to return false is it is identical to, the R, G, and B are all identical. Then that's the only time it's going to return false, right? Okay, so now with this, the answer to this question is easy because we just called the procedure. And which two colors are we comparing? We're comparing the background color, get it? And comparing against the color on that particular pixel. If they are different, then we know XY is in the circle because it's not on the background. It's not on the background. Is that okay? So getting back to the timer.
Do anything with local X and local Y now?
Yeah? Oh, right, because I cannot use it. Yeah. Well, I'll just keep it there. A C++ compiler with warn all would actually tell you, hey, you got a parameter that you're not using, or local variable that you're not using. Something is not right about your program. All right, so after we draw, then we'll go ahead and use is XY in circle in order to determine whether we should stop the timer or not. And I'm going to do it in a tricky way. So we'll say clock 1, and, well, not sure whether this works or not, but I think it will. So we'll basically just set timer enabled based on the answer of is XY in circle. So we call the procedure is XY in circle. And the X and the Y are basically the coordinates of the circle that no, not the circle, but, oh, I put it in the wrong place, did I? It should be in the timer. There we go. Okay, there we go. So when every single time the timer ticks, I will move the sprite to a different spot, right? And then at that spot, I'm going to check is the circle, is the XY coordinate of the sprite inside a circle or not. Okay. And the emulator is running this entire time, and it has stopped because it is in the circle. Oh.
It's confused now.
Well, it's confused because the timer has stopped. So if I go back to the designer, let me see if I can reset it. Go to clock, and click this, and then click it again. Well, it certainly moved. So it may not be the best way to debug a program. Well, but it's still connected, right? We still have the emulator going. So instead of doing it this way, we'll do it this way then. Because the emulator is still going, I can still use ADB to upload the program. Oh, come on. It's not even a big program. And then after this is done, the next thing is how do I know whether two circles are going to overlap or not? Because you're not supposed to have two circles that are overlapping. That one is actually pretty easy too, because you just have to know the distance between the centers of the two circles. Oh, come on. Give me the APK file already. Should I ask it again? Yeah, let's do that. Oh, maybe it's still working on it. Nope. I think it dropped the order. Where's my miso soup? That's supposed to come with my bento box, right? Okay, useless screen 1. Now let's change the name to dots. There we go. Alrighty. So get rid of this. Hopefully it doesn't kill. Oh, it did kill the emulator. Darn it. So we run the emulator separately. Okay, because the emulator is still starting up. There we go. So it should connect. Good. There we go. It's gonna report fail at the end. Something about the RM command. Here we go. And I think it's still called useless at this point. Oh, no, timer enabled is. Oh, I need to invert it. That's all. Okay, because timer enabled is, it's going to be true only if XY is actually in circle, which is the reverse of what I want. Okay, that's why it's not working. Okay, because it's the reverse of what I want. I want.
No.
That's okay. We'll just say reset. That'll make it happy. Okay, but getting back to the other question of, how do you know that two circles are not going to overlap? Okay, so we'll think about it a little bit. Circles are easy to figure out because the distance from the center of a circle to the edge of the circle is the same regardless of which part of the edge you're talking about. So that actually makes it easier to deal with. So we'll deal with that when we are done with this thing here. So this time I did use the name useless. Go back to here. Huh. It did not reload the app itself.
Insufficient storage.
Oh, okay. So we have to start to uninstall stuff. Ay, caramba. All right. Settings. This is the old version of Android. It doesn't do the uninstall the same way as the newer ones. So you have to go to Applications, Manage Applications, and then we can now uninstall stuff. Uninstall.
Give you very much space on that emulator.
Nope. One screen. I think that's mine too. Uninstall. All of these are my apps. There we go. Except for AI Companion. Okay, so uninstall. There we go. All right. Now we should cooperate. There we go. Okay, so we go back, and click on useless. Yay. Okay, so now we have to ding. Yep, that works. Because the dot is in it, right? Okay. All right, so the next thing we want to do is to find out, how do we paint the circles so that they're non-overlapping. Okay, so the key is to determine the distance between two circles, the center distance. So how do you measure the distance between 2 points? Because the center of a circle is a point, so you're really measuring the center-to-center difference between 2 circles, which is 2 points. Yep.
So you can use the square root of the sum of the difference in x distance squared plus the difference in y distance squared, plus if you have like 3 dimensions, also the difference in z distance squared.
Yep.
Yeah.
Yep. And there's a name for that rule.
Pythagorean theorem.
Yep. Okay, so basically the bottom line, I'm not even going to use the app inventor for this. I'm just going to display it here, which is the equation. So we'll just say that x1, y1 is the center of circle 1. Okay. x2, y2 is the center of circle 2. So now the question is, based on the current, these 2 things, and we'll use a single r. Okay, r is the radius of both circles. So I highly recommend that you use one single r for all your circles, unless you really want it to be slightly more painful to have to accommodate different radiuses. I mean, you can do that if you want to, because you just have to compare it to the sum of the 2 radiuses instead of twice the radius of the uniform radius. So, it's not that bad, okay? You just have to track one more thing for each circle, which is the radius of each circle. Yep.
If you want to check whether they're, well, never mind, sorry. That's okay.
Okay. So if the square root, okay, well, we don't really need to use square root. I'll show you guys in another way to do it. So if the square root of this is greater than or equal to r, then the circles are not overlapping. Okay.
2r.
Else the circles are overlapping. Okay, there we go. 2r is correct. 2 times r.
You can always square everything so that you don't have to deal with square roots.
Yes. But since we did talk about the square root first, so we'll say square root. So you basically look at the square, which is just a square of x1 minus x2. The direction doesn't really matter because once you square, the sign goes away. So this is the square of y1 minus y2. So the actual distance squared between the x coordinate and the square of the y the difference of y, when you add these 2 and then you take the square root, if that is greater than or equal to 2x or 2r, the radius, twice the radius, then the circles are not overlapping. If it's less than, then they are overlapping. I wouldn't be too picky about that one single dot that is actually touching, so I wouldn't worry too much about it. Are there any questions about this? Okay. Oh, this makes it a little bit easier to read. There we go. Okay. So now the question is, well, can App Inventor deal with square root and also square? So we go into App Inventor, and then we look up, where's my, did I lose that? No, right here. So we go to Math, and then we say, okay, do we have squares and stuff like that? And it does not look like it. We do have square root, okay? So let's pick out square root here, click this down bar here, and it doesn't have square. No. If it doesn't have square, what do we do?
Times.
You make it. You go to procedure, and then you say, okay, let's make a square procedure. Square, which takes a number as a parameter, right? The square of x is just x times x. So in math, you specify a multiplication, and you say we just need x times x. So now we have a square. Is that okay? So square root is built into App Inventor. Square apparently is not built in, but you can easily make it. Is that okay? All right. Okay, so the other way to do this is one way. So the other way to do this is to do it without square root, but only using squares. So if you're using squares, you basically will take out this particular square root and then square the other side. So then it will be basically equivalent. The comparison will still be equivalent. So you square this part here. Or for those of you who really want to optimize and say, you don't need to do the 2 times inside the square, fine, take it out. Make it the 4 times on the outside. But they do exactly the same thing. These two comparisons or these 2 logical statements are identical when it comes to the actual logic. Is that okay? So this means, when you are coming up with a new position to draw a new circle, you have to make sure that it does not overlap with any one of the previous circles. If you already have 6 circles determined, the 7th one will have to compare to all the first 6 ones. So how do you do that? You have to use a loop. Okay, very good. Okay, so when you use a loop, it implies that you have to somehow store the positions of all the previous circles.
You use a list.
You use a list. Very good. So in your list, what is each item of the list of circles?
Should be
Y
coordinates. Yeah.
The coordinates, right? So how do you store coordinates?
That's the list.
As a list of 2 items, right? The x and the y coordinate.
Yeah.
So,
You want a radius.
yes, if you want a varying radius, then you have to store
Or
the
if you want to
radius
store the
as
color
well.
there also.
Well, you don't need to store the color,
No.
right? As long as your color is different from the background, you're still okay. So that part is easier.
Oh, so
I
if
thought
you
they
use
were
a
supposed to be
random color, you
different
have to make sure it doesn't.
Well, a random color could be the same as the background.
Yeah, so you have to make sure that random color is not the background color. Yes. If it is the same, then you just go back and say, okay, you pick me another color. But these are all optional, okay? So don't make yourself, make it work first. Turn it in, and then you go like, well, I got 6 more days. What am I going to do? Then you can play with all of these other things. Okay. Any questions about the homework assignment? The difficult part about this one is going to be maintaining the list. Okay, that's new to many of our homework assignments, but this is important because this is how you can make your internal representation using a list where each item is the coordinate of a circle as the representation of all the circles that is actually being displayed. So every time the end user drags the small sprite, you are displaying it on the screen, but underneath the calculations is not based on the screen. Underneath, well, I guess it is, but when it does collide, you have to make that circle go away. Remember? How do you make a circle go away? You paint the same circle filled, but using the background color of the canvas. Then it will appear to go away. Is that okay? So that means you have to match. You have to go through the whole list, find out which one is still on screen. You don't really have to do that because if it's not on screen, it won't actually trigger, right? So you have to kind of go through the list and find out, okay, the center of my ball sprite is on which circle. Find out which one it is. Then you will retrieve the radius. Well, the radius is constant, assumed to be constant, but you will retrieve the xy coordinate of the circle. Then you just draw that circle using the background color of the canvas at that spot. Then that circle will appear to go away. Is that okay? And of course, another really brute force approach. Well, it's not any better, so I'm not going to even say it. You can clear the whole screen and just redraw all the circles, but that's not going to be. It's not going to be any faster or easier because you still have to remove that circle from the list, or somehow mark that it is gone. It's actually making it more complicated. That list is also useful because when you long click the button at the end of a game, when the game has concluded and you long click the button, Now you have the list already. It's like, oh, I don't have to regenerate the list because I got I got it already. Just restart the game using the list of those 7 circles, and the game starts again. So that's going to be the more difficult part of this homework assignment, is to maintain the list of coordinates, or the centers of the circles. That's going to be more complex than okay, is the center of this sprite over a circle. That part is done. Okay, we just did it in class, and we made use of the colors to get to work on that one. That's an easy one. Okay, any other questions? Yep.
I just have trouble when I do the notifier and it has a button. You click the button to program what that button does. It never does anything. I try to use the after choice.
A button? Okay, I think you're talking about a list picker.
No, when you get a notifier pop up, it has a little box. And it has buttons you can click. I can't ever seem to program one of those buttons to do something.
Oh, okay, with a notifier. Okay, so with a notifier, all right, so I think I understand your question. So when you have a notifier, okay, I have to put one into the design first to talk about it. And I think we got enough time to do it. Okay, so when you use a notifier, you have to make use of after choosing as an event to know which button was clicked.
Yeah, I do, but I don't understand
It's a separate event.
how to go about. Because it says set choice, and choice is like a boolean.
No, choice is not a boolean. Choice is the text. It's the text of the button that the end user clicked. It's not a boolean.
Show how program.
We did that once already. You might want to just kind of refer back to the program. It's the counting program. Remember, we did a program like really early on. When you click the button, it just increments a pointer.
Yeah.
So that actually becomes the text of whatever button
Yeah.
they pick.
So it's
The
not a
choice.
good idea to have the same text on 2 buttons. Then you cannot really tell which one. But we did talk about it, so you might want to refer back to that program, which is really early on. And the context of that program to make use of something like this is when you start the app, but in TinyDB you already have a saved value, a saved count. Then you present a dialog box to ask the end user, do you want to reset to 0, or do you want to continue the count from last time? And that's the context of why after choosing was used in that particular app. And I think in exam 1 we also used something similar, and I actually showed you guys how to do it too. So there are several occasions where I showed you guys how to do this. But this is an event that's generated when the end user clicks on something, and you have to display a dialog box using not choose dialog, and I think it's one of these. Nope, maybe it is choose dialog. So when you use this block, show choose dialog, to present a dialog box that has multiple buttons, okay, this block will come back right away. It doesn't wait until the end user has clicked on something. This block comes back as soon as the dialog box itself is displayed. Okay, so you cannot use the same event handler to see which button the end user has clicked. But when the end user does click on a button, it's going to generate a second event, which is this one here. That's the time when you need to look at choice and compare choice to all the possible buttons that the end user could have clicked, and then use a conditional statement to decide, okay, if the end user clicks OK, this is what I need to do. If the end user clicks cancel, this is what I need to do. So you have a slight problem of separating the thread because it's one single event handler anymore. Your logic is now split between 2 event handlers. Any other questions? But that's not needed for this homework assignment. I guess it's in your project.
Yeah, because when you win, you want to be able to click in.
But that's determined by either a click or the long click of the button. There are no notifiers used in this project. In the project that is due next week, you don't need to use a notifier at all. Okay. All right, so we are moving on to the lab. If you have any questions about your project or the homework assignment, I can answer those questions at the lab.